Yes, sir. Yes, sir. We can start. Pragati ma'am, just start.
Please.
Okay, sir. Good morning, everyone. I, Prakriti Diwan, welcome you all on second virtual lecture series organized by Columbia Institute of Pharmacy in association with Indian Pharmacy Graduate Association, Chhattisgarh State Branch. It gives me immense pleasure to extend a warm welcome to our eminent speaker, Dr. R.K.Maheshwari, sir, from SGSITS Indore, Sri Harjit Singh Hura, Secretary Jan Pragati Education Society, Dr. Ravindra Kumar Pandey, Principal Columbia Institute of Pharmacy, respected faculty members and dear students. Before starting, I invite Sri Harjit Singh Hura, sir, to address the gathering. Sir, please.
Pragati, Diwan madam.
Thank you, ma'am. Good morning, everyone. Should I continue?
Please.
Okay. Yeah.
Yes, sir. Yes, sir. Yes.
Good morning, everyone. I welcome you all in this virtual lectures series organized by Columbia Institute of Pharmacy in association with IPGA Chhattisgarh branch on economic and eco-friendly techniques in various fields of pharmacy, utilizing solubilizing properties of safe and economic solids, mixed solvent solvency concept. It's an honor and pride for all of us that Dr. R.K.Maheshwari, sir, is amongst us to deliver a talk on above topic. Dr. Maheshwari is a renowned scientist and academician of India. He was my super senior in Dr. Hari Singh Gaur University. Thank you very much for joining, sir. And thank you very much for sparing your valuable time to share your experience and expertise with our all delegates and members of IPGA. I welcome Dr. Manju Singh ma'am, President IPGA Chhattisgarh branch, Dr. Vishal Jain sir, Vice President IPGA Chhattisgarh branch, Dr. Ravindra Pandey ji, General Secretary IPGA Chhattisgarh branch, and all the respected office bearer of IPGA and all the delegates. I am very happy that Dr. Maheshwari given his kind consent and spared his time to share his expertise with all the delegates, because such resources, such important and experienced resources are of us, because they have fully and I'm hopeful that they will be having some questions later on to clear their doubts, whatever they must be having, and they should take away this topic with very much clarity with them, so that they can perform and deliver this particular expertise with their students, especially those who are from academic side. And I appeal to all the delegates and all the faculty members, especially, to produce quality students for pharmacy fraternity, so that we can raise our flag all across the globe, because India is leading very speedily in pharma world across the globe. So I hope that we'll be producing very competent and skilled students for our pharmacy profession. I once again thank Dr. Maheshwari sir for joining us, and I thank IPGA State Branch to giving me this opportunity to share my views. Thank you so much.
Thank you, sir. As sir said, our today's webinar topic is economic and eco-friendly technique in various fields of pharmacy, utilizing solubilizing properties of safe and economic solids. Our today's webinar will be focused on minimizing the use of harmful organic solvents in various analytical techniques, extraction, synthesis, development of pharmaceutical dosage forms of insoluble drugs, etc., to safeguard human health against the injurious effect of hazardous organic solvents. For today's webinar, we have Dr. R.K. Maheshwari sir, Professor and ex-head of SGSITS Indore as the guest speaker. Sir has done his B Pharm and M Pharm from uh, um Dr. Hari Singh Gaur University, Sagar in 1979 and 1981, and PhD in 2008 from DAVV in Indore. Sir is recently working as Professor SGSITS Indore. Sir has more than 35 years of teaching and 3 years of industrial experience. Sir has more than 190 research papers, 4 patents, and various seminars, conferences, and expert talks into his credit. With this word, I invite Dr. Maheshwari to deliver his deliberation. Sir, please.
Okay. Good morning to all of you.
Good morning,
Firstly,
sir.
I would like to thank
Good morning, sir.
Namaskar. Firstly, I would like to thank Dr. Shiv Shankar Shukla ji, of course, Rajini Kant ji, Dr. Ravindra Pandey ji, Harjit ji, and of course all the IPGA members. Because of whose effort I am here with you to share the research ideas. What you shall get in my lecture should be known to you firstly. The new things or new research area which you will get from my lecture is we can utilize the solubilizing power of cheap and economic solids to replace harmful organic solvents. So this is the new thing which you will find in my lecture. And my lecture is based on solubilization. The new thing is this, that up to this time, whatever the substances whatever the substances exist in the form of liquids, they all are known as solvents. But there is no universal solvent. Whatever the name of any solvent you take, that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. For example, we know from the books that water is good solvent for about 1/3 drug, water is bad solvent for about 2/3 drugs, like this. So whatever the name of any solvent you take, that solvent possesses good solubilizing power for some solutes and bad solubilizing power for other solutes. Similar to the liquids, the solids, the molecules of solids and gases, when they are in liquid state, they also possess solubilizing power. Because what happens in the dissolution process, the simple dissolution process, for example, we dissolve, say, sodium salicylate in water, we get a clear solution. Why do we get a clear solution? Very simple mechanism of dissolution is that due to, or you may say as a result of hydrogen bonding and weak van der Waals forces between the molecules of sodium salicylate and molecules of water. If you are dissolving, say, for example, salicylic acid in ethanol, you get a clear solution. The reason for this is, or mechanism for this is, as a result of dissolution of salicylic acid in ethanol is the result of hydrogen bonding and weak van der Waals forces between the molecules of salicylic acid and molecules of ethanol. So very simple theory is this one. So here, since the substances which exist in liquid state, they all are known as solvent because their molecules are in liquid state to take part in hydrogen bonding and weak van der Waals forces. But when I say that also have got solubilizing power, or gases also have got solubilizing power, means when the molecules of solids, they are in liquid state, either by melting or dissolution, like this, or so these molecules of solids or gases may also be involved in hydrogen bonding and weak van der Waals forces with the molecules of solutes for their dissolution. This I will explain in my lecture. So basic thing which you will learn in my lecture, that all molecules present in this universe have got solubilizing power, but only thing is that those molecules should be in liquid state. And I will tell you how can we minimize the use of harmful organic solvents by utilizing the solubilizing power of solids. So I am going as soon as some doubt comes to your mind, please note down the questions. At the end of the lecture, we will have question and answer session. Now I am going to start the presentation. इसको फुल करने का थोड़ा सा एक बार इधर कहीं से बताओ यार। यहाँ पे भी कुछ है, कुछ करने से चलो यहाँ पे अच्छा हो गया। ये वाला नहीं, इसके बाद देखो उसमें it is okay. Okay, now so these slides are visible to you. This topic is more or less same as mentioned in the today's lecture, that is economic and eco-friendly techniques in various fields of pharmacy utilizing solubilizing properties of safe and economic solvents, mixed solvency concept. So here, firstly, let us understand where and which field we utilize the organic solvent. So various organic solvents, they are employed in various analytical techniques like TLC, HPTLC, HPLC, UV spectrophotometric analysis, antimetric analysis, etc. Also, organic solvents are involved in extraction of active constituents from herbal powders. Also, they are involved in the synthesis of organic compounds, and also they are involved in the formulation of pharmaceutical dosage forms and so on and so forth. Now, why do we want to minimize the use of harmful organic solvent? The reason is there are certain drawbacks with organic solvents, and these drawbacks include organic solvents have numerous adverse effects caused by single exposure, like headache, drowsiness, nausea, irritation, etc. Single exposure means suppose the students are human being, if they are involved in any analysis, and suppose there is use of methanol, chloroform, etc. So due to you may say the single exposure, there may be headache, drowsiness, nausea, irritation, etc. But these things are reversible; they are not so harmful. But when a person constantly works for analysis or any formulation or synthesis, when there is use of organic solvents, so because of the volatility of organic solvents, their vapors, they go inside the body of the human being and they may cause severe ill effects. For example, long-term exposure. Long-term means months together, years together, when the human being is involved in such types of works, then definitely there may be ill effects like neurological disorders, chronic renal failure, liver damage, neurosis, mutagenesis disorder, etc., etc. So in this way, if we see the constant use of means and the persons, they are involved in such field where day-to-day means and day-to-day work, there is involvement of organic solvents, then definitely that human being suffers from so many ill effects as I have mentioned here. So we can protect the human being against the harmful effects of organic solvent by minimizing their use. So I will tell you how can we minimize the use of harmful organic solvent. Not only these organic solvents, most of the organic solvents are injurious to health, but also they are costly, and of course they are removal from the industries or factories or even say the companies involves a special say treatment should be given to them to make them safe before they are thrown away. So another cost involving factor. So they themselves are safe, costly, and their disposal is also costly. Now there are three classes of organic solvents mainly: class 1, class 2, and class 3. Class 1 organic solvents, they are most hazardous to human health. So class 1 organic solvent involved, that means the commonly employed class 1 organic solvents include benzene, which is carcinogenic, carbon tetrachloride, 1,2-dichloroethane, etc. Class 2 organic solvents, they are also quite harmful, but they are somewhat less harmful than class 1 organic solvent. Commonly employed class 2 organic solvents include acetonitrile, chloroform, toluene, methanol, pyridine, hexane, N,N-dimethyl-formamide, etc. Class 3 organic solvents, they are relatively safer than class 2 and class 1 organic solvents. Means, or you may say among the three classes, these are the safest. But then also they are harmful. So we should minimize the use of such class 3 organic solvents also. Commonly employed class 3 organic solvents include acetic acid, acetone, ethanol, ethyl acetate, etc. Now, the future role of solvent character of solids. Solubilizing power of solids shall minimize the use of harmful organic solvents in future. Class 3 organic solvents are relatively safer than class 2 and class 1 organic solvents. So I will tell you the techniques by which the class 3 organic solvents, which are relatively safer than class 2 and class 1. So by utilizing the solubilizing power of solids, we can improve the solubilizing power of class 3 organic solvent to act as class 2 or class 1. I will explain in my lecture later on. We can potentiate the solvent power of class 3 organic solvents by dissolving safe solids in them to replace class 2 and class 1 organic solvents. Now, what happens in dissolution? Let me repeat. Dissolution of a solute and a solvent involves hydrogen bonding and weak van der Waals forces between the molecules of solute and molecules of solvent. Mixed solvency concept proposed by May in the year 2009 states that each and every substance, whether the substance is gas, whether the substance is liquid, whether the substance is solid, present in this universe has got solubilizing power. In other words, we can say whatever are the number of molecules present in this universe, all molecules possess solubilizing power, and all molecules in this mixed solvency concept, they are known as solubilizers. As we have seen that substances which exist in liquid state, they all are known as solvent. In the same way, all molecules present in this universe, they are known as solubilizers. And whatever the name of any solubilizer you take, that solubilizer possesses good solubilizing power for some substances and bad solubilizing power for other substances. This I will explain in my lecture. Once the molecules of a gas or molecules of a solid come in liquid state, they may also be involved in hydrogen bonding and weak van der Waals forces with the molecules of solute for the dissolution of that solute. About solvents, whatever this thing again, whatever matter exists in liquid state at room temperature is known as solvent. For example, water, ethanol, methanol, chloroform, acetonitrile, DMSO, DMF, etc. All are known as solvents. Each liquid or so-called solvent possesses good solubilizing power for some solute and bad solubilizing power for other solutes. Similarly, each matter, whether matter is liquid, gas, or solid, is known as solubilizer in mixed solvency concept. Molecules of all solids in liquid state, of course, and molecules of all gases in liquid state also possess good solubilizing power for some solute and bad solubilizing power for other solutes. Now, I will give examples. How can we say that all gases possess solubilizing power? The example is that of supercritical fluid technology. Supercritical fluid technology. In this technology, CO2 gas at a particular pressure and temperature, when it is liquefied, is used to act as solvent to carry out different functions. For example, preparation of nanoparticles, extraction of active constant from herbal powder, purification of the materials, and so on and so forth. Ultimately, a liquefied CO2 gas is being used as solvent. Why? Because in liquefied CO2 gas, the molecules of CO2 are in liquid state, and these molecules of CO2 are involved in hydrogen bonding and weak van der Waals forces with the molecules of solutes for their dissolution. So simple theory, I told you that when the molecules of gas, they are in liquid state, they may also take part in hydrogen bonding and weak van der Waals forces. That's why a gas CO2 at a particular pressure and temperature, when it is liquefied, is being used as solvent. Okay, another example of gas to demonstrate its solubilizing power, say for example, concentrated HCl contains about 38% bit by bit of a dissolved HCl. If you dissolve any gas in a solvent, then also the molecules of gas will be in liquid state. Like in, suppose you take 100 grams of concentrated HCl, that 100 grams of concentrated HCl contains about 38 grams of dissolved HCl. Dissolved HCl means the molecules of HCl are in liquid state. Now I am giving the example of a drug which is poorly water soluble. Nalidixic acid is a poorly water soluble drug, but the solubility of nalidixic acid in concentrated HCl is about 5%. 5% means very good solubility is there. Why? The reason is this dissolution of nalidixic acid in concentrated HCl is the result of hydrogen bonding and weak van der Waals forces between the molecules of HCl and molecules of nitric acid. Of course, here we are not talking about the formulation, but we are seeing just a proof that how can we say that gases have got solubilizing power. Now, okay, so by liquefaction, a gas, the molecules of a gas may come in liquid state, or by dissolution in a solvent, the molecules may come in liquid state to demonstrate their solubilizing power. But the utilization of gases is costly, so we are keeping them aside. Now, mostly now in my lecture, you will find the utilization of solid. So now I will give firstly the proof that how can you say that solids have got solubilizing power. So firstly, you see how a solid will demonstrate its solubilizing power when the molecules of a solid will be in liquid state. Now how the molecules of a solid may come in liquid state is by three ways. Number one, by melting. Number two, by dissolution in a solvent. Number three is by deformation. So all these examples I will give in this lecture. So, and when I give these examples, please do not relate with the formulation. No, just they will be the proof that solids have got solubilizing power. Number one, by melting. Now, first example is that of urea. If you take 1 gram urea in a test tube, you heat it on heating mantle at 132 degrees centigrade, which is the melting point of urea, you will have clear colorless melted urea liquid, clear colorless liquid melted urea liquid, which can be taken like any liquid. So what I am saying, at 132 degrees centigrade, you are having 1 gram clear colorless melted urea liquid. In this 1 gram melted urea liquid, 1 gram of dichloromethane sodium is nicely dissolved. You get a clear solution. 1 gram, here 1 gram, very good solubility of dichloromethane sodium melted urea. What is the reason for this? We are not making formulation. What is the reason for the dissolution? The reason is the molecules of urea in melted urea, they are in liquid state, and these molecules of urea, they are involved in hydrogen bonding and weak van der Waals forces with the molecules of dichloromethane sodium. That's why you are getting clear solution. Suppose there was no solubilizing power in urea molecules, then you could have obtained a suspension of dichloromethane sodium, but we are getting a solution. Now, suppose there was no solubilizing power in melted urea, then why we would have obtained a suspension? Because the melting point of dichloromethane sodium is 283 degrees centigrade. So dichloromethane sodium does not melt at 132 degrees centigrade. So suppose there was insolubility, then you could have obtained a suspension, but you are getting a solution. So this is a proof that a solid, means a urea, in liquid state, when its molecules are in liquid state, these molecules of urea are acting as you say the solubilize dichloromethane sodium due to hydrogen bonding and weak van der Waals forces. Another example of melting is phenol. The melting point of phenol is 44 degrees centigrade. Again, a test tube has been taken, 1 gram phenol has been transferred in it, and now this test tube has been immersed in a water bath. At about 44 degrees centigrade, you will have clear, colorless melted phenol liquid, which can be taken like it. And now the molecules of phenol are in liquid state, and this melted 1 gram phenol liquid is very good solvent for nalidixic acid. About 500 milligram of nalidixic acid is nicely dissolved by 1 gram melted phenol liquid. What is the reason for dissolution? Hydrogen bonding and weak van der Waals forces between the molecules of phenol and molecules of nalidixic acid. Of course, we are not talking about the formulation. Okay, suppose there was no solubilizing power in melted phenol molecules, then definitely we would have obtained a suspension. So these are the proof. Means any solid, if you melt, its molecules will be in liquid state, and that can behave as solvent. Number two, another way by which the molecules of a solid may come in liquid state is by dissolution in a solvent. There are three examples of three solvents. Number one, water as solvent. So solubility of ibuprofen in water at room temperature, of course, is 0.028% weight by volume. Very less solubility of ibuprofen is there. And what are the reasons for less solubility? The less solubility of ibuprofen in water is due to limited extent of hydrogen bonding and weak van der Waals forces between the molecules of water and molecules of ibuprofen. Limited extent. When the extent of hydrogen bonding and weak bond force is great, then there will be great dissolution like this. Anyway, so because of poor hydrogen bonding and poor extent of hydrogen bonding and weak bond forces between the molecules of ibuprofen and molecules of water, now there is poor solubility of ibuprofen water. Okay. Now we are making a solution of a solid sodium benzoate. 2 molar sodium benzoate solution we are preparing. 28.8% weight by volume solution of sodium benzoate in water. In this solution of sodium benzoate, concentrated solution of sodium benzoate, the solubility of ibuprofen is 2.390%. So how many times solubility enhancement is there? 2.390 divided by 0.028, about 85-fold enhancement in solubility is there. Now, what is the reason for this? Now, in your concentrated solution of sodium benzoate, the molecules of sodium benzoate, which is solid at room temperature, when it has been dissolved in water, the molecules of sodium benzoate, they are in liquid state, and these molecules of sodium benzoate are involved in hydrogen bonding and weak one-to-one force with the molecules of ibuprofen. That's why there is a large solubility of ibuprofen in water in sodium benzoate solution. So this is one proof that solids have got solubilizing power. Another solvent is ethanol. Solubility in ethanol is poor, sparingly soluble. 1.7% weight by volume solubility is there at room temperature, that of furosemide and ethanol. Again, due to limited extent of hydrogen bonding and weak one-to-one forces between the molecules of furosemide and molecules of ethanol. But when we dissolve a niacinamide, 15% weight by volume solution of niacinamide and ethanol, now the molecules of niacinamide, nicotinamide, they have come in liquid state in solution form, and in this solution of 15% weight by volume niacinamide and ethanol, the solubility of furosemide is about 5%, 5%. 3 times solubility enhancement, 5 divided by 1.7, about 3-fold enhancement in solubility is there. What is the reason for this 3-fold enhancement solubility? The reason is, previously when only ethanol was there, so the extent of hydrogen bonding weak one-on-one forces was limited, but now 2 times more are the nicotinamide molecules. These molecules are in liquid state, and now these molecules of nicotinamide, they are also involved in hydrogen bonding and weak one-on-one forces with the molecules of furosemide. That's why you are getting 3 times solubility of this furosemide and niacinamide ethanol solution. The reason is, again, a solid means niacinamide have the molecules have come in liquid state after dissolution in ethanol. Now the third solvent is the propylene glycol. At room temperature, the solubility of pyroxicam in propylene glycol is about 5 milligram per ml. Very poor solubility is there, 5 milligram per ml nearly. But when we dissolve 2 solids in propylene glycol, making a solution containing 10% sodium acetate weight by volume, of course, and 10% sodium caprylate weight by volume in propylene glycol. When the solubility of pyroxicam was checked in this solution, containing total 20%, 10 plus 10, 20% solids, they are in the molecules there, these molecules are in liquid state. In this solution, the solubility of pyroxicam is about 120 milligram per ml. 120 milligram, so 120 divided by 5, about 24-fold enhancement in solubility is there. The reason for enhancement of the solubility is the molecules of sodium acetate, molecules of sodium caprylate, they are in liquid state in propylene glycol solution, and these molecules are involved in hydrogen bonding and weak one-to-one forces with the molecules of pyroxicam. That's why there is a large solubility of pyroxicam in this particular blend. Okay, so these are the proof that solids have got solubilizing power, and of course the reason is that after dissolution the molecules of solids they come in liquid state to demonstrate their solubilizing power. Third way by which the molecules of a solid may come in liquid state is by eutectic formation, eutectic liquid formation. For example, if you take 5 gram thymol, 5 gram menthol in a pistol water, with the help of pistol water to triturate, you will get a clear colorless liquid which is known as eutectic liquid of thymol and menthol at room temperature. Its a pH is 6.5, means nearly neutral. So what I am saying, molecules of thymol and molecules of menthol, they have come in liquid state in particular clear colorless eutectic liquid of thymol and menthol. Now the properties of this eutectic liquid, we are not talking about the formulation, just we are discussing the the solubilizing power of solids. The proof to say that solids have got solubilizing power. Left hand side, if you see metronidazole benzoate, which is a poorly water soluble drug, but in this particular liquid, the solubility is more than 200 milligram per ml. Similarly, atenolol, more than 90 milligram per ml solubility. Albendazole, 120 milligram per ml more than, like this. So whatever the compounds are listed in this left hand column, for all these compounds, this eutectic liquid is good solvent. For example, you see metronidazole benzoate 200 milligram per ml, about 20% solubility is there. What is solubility? The reason is the molecules of thymol, molecules of menthol, they are in liquid state, and these molecules are being involved in hydrogen bonding and weak bondable forces with the molecules of metronidazole benzoate. That's why you are getting a large solubility of metronidazole benzoate in this eutectic liquid. Otherwise, this metronidazole benzoate is a poorly water soluble drug. So for left hand compound, this eutectic liquid is good solvent. For right hand column, this cetronidazole, not even 5 milligram can be dissolved by 1 ml of this eutectic. So this eutectic liquid is poor solvent for cetronidazole, furosemide, nimesulide, aspartame, etc. So now in this way we can say this. Of course, we are not talking about the formulation. Please mind it well. Now this eutectic liquid is good solvent for some compounds, left hand column compound, and it is bad right hand column compounds. Okay, so in this way we can say this eutectic liquid is good solvent for some compounds and bad solvent for other compounds, like this. Okay, similarly, if you see the solubility of liquids in this eutectic liquid mixture of thymol menthol, left hand column ethanol, propyl, glycol, benzyl, alcohol, etc., they are miscible, means they are soluble in this eutectic liquid. In other words, you may say these liquids have got good solubility in this eutectic liquid of thymol menthol, but right hand column glycerine, it is immiscible in this eutectic liquid. Water, it is immiscible in this eutectic liquid. Similarly, if you check the solubility of a number of compounds, suppose 10 compounds, 100 compounds, if you check this eutectic liquid, some compounds will fall in this stage, some will fall in this stage. Now we can say that this eutectic liquid is good solvent for some compounds, bad solvent for other compounds. And the same statement was there with the so-called solvent. The substances which exist in liquid state at room temperature, they are known as solvent, but no solvent is universal solvent. DMSO, DMF, chloroform, ethanol, benzene, etc., they are not good solvent for each and everything. So whatever the name of any solvent you take, that solvent possesses good solubilizing power for some solute and bad solubilizing power for other solute. Similarly, this eutectic liquid is good solvent for some compounds, bad solvent for other compounds. So now you may say this eutectic liquid is a solvent, and once you prove that it is a solvent, means whatever it contains two solids, thymol and menthol, in liquid state, of course. So they must possess solubilizing power. You are getting good solubility of some of the compounds, bad solubility of other compounds, like this. So in this way, it is proved that solids have got solubilizing power, and this was the third way by which you may say that a molecules of a solid may come in liquid state is by eutectic formation. Now coming to hydrotropic solubilization, I have started work on this hydrotropic solubilization, which is about 100 years old concept. I did my PhD work on hydrotropic solubilization. I started my work from 2004, and of course from 2004 I have started new applications, novel applications of hydrotropic solutions to replace harmful organic solvent. So first we should understand what is this hydrotropic solubilization, which is more than 100 years old concept. So let me go first to the examples of hydrotropic solubilization. In the middle of this list, you see urea. Means whatever you are seeing, these are some of the hydrotropic agents. So urea, we can prepare 60% weight by volume solution of urea and water, a concentrated solution of urea and water. 60% weight by volume. So from the point of view of students, let me explain 100 ml volumetric flow, 60 gram urea, sufficient water, dissolution, clear solution, volume makeup up to 100 ml. So this is 60% weight by volume solution of urea and water. The properties of this urea solution, concentrated urea solution, in this particular solution of urea, the solubility of dichlorofenac sodium is about 4.8%. In this solution, solubility of dichlorofenac sodium is 4.8%. But in water, at room temperature, the solubility of dichlorofenac sodium is 1.6%. Water, 1.6%. Due to limited extent of hydrogen bonding at weak one over forces between the molecules of, you may say, the dichlorofenac sodium molecules of water. Okay, so 1.6% in water, 4.8% in urea concentrated solution, 60%. So this is one example of hydrotropic solubilization. The molecules of urea, 60% solution, they are in liquid state. And now these molecules of urea are being involved in hydrogen bonding and weak one over forces with the molecules of dichlorofenac sodium to increase its solubility like this. But of course, this is known as hydrotropic solubilization. Why it is known as hydrotropic solubilization? Hydro means water. So this hydrotropic solubilization relates with solubility enhancement in aqueous solutions, or you may say in water. Hydrotropic. This means hydrotropic solubilization is not solubility enhancement in propylene glycol. No, not solubility enhancement in chloroform, not solubility enhancement in ethanol. No, not in any other solvent, only in water or aqueous solutions. When there is solubility enhancement, this is there in case of hydrotropic solubilization. Okay, so this was one example of hydrotropic solubilization. Another example, left-hand column, sodium citrate is also a hydrotropic agent. The solubility of salicylic acid in water at room temperature is about 0.3% weight by volume. Salicylic acid, water, room temperature, solubility, 0.3% weight by volume, limited solubility, poor solubility. But suppose you prepare a 45% solution of sodium citrate in water, 45% concentrated solution, in which the molecules of sodium citrate are in liquid state now. In this sodium citrate concentrated solution, aqueous solution, the solubility of salicylic acid is more than 15%. More than 15, more than 15%. So 15 in this solution suppose and 0.3 in water. So 15 divided by 0.3, 54 is there. 54, this is also an example of hydrotropic solubilization, because here the solubility of salicylic acid is being enhanced in aqueous solution of sodium citrate. And the reason for solubility enhancement, sodium citrate molecules are in liquid state, and these molecules are involved in hydrogen bonding and weak one over forces with the molecules of salicylic acid. That's why you are getting a large solubility of salicylic acid in this concentrated solution of sodium citrate in water. So this is another example of hydrotropic solubilization. Another name, if I take that of the hydrotropic agent, it's sodium benzoate. Very good hydrotropic agent, sodium benzoate. The if you prepare, say for example, 25%, 30%, 35% solution of sodium benzoate in water, aqueous solution. In this solution, the solubility of several poorly water soluble drugs is enhanced. Now I am naming those poorly water soluble drugs of which the solubility is enhanced in sodium benzoate solution. Now ofloxacin, gotifloxacin, tindazole, metronidazole, ornidazole, your naproxen, flurbipropan, ibuprofen, salicylic acid, atenolol, dichlorofenac sodium, aspirin, and so on and so forth. So in this way, what you can say, the solubility of several poorly water soluble drugs is enhanced in concentrated solution of sodium benzoate. So these all are the examples of hydrotropic solubilization. Now the definition of this hydrotropic solubilization, when there is enhancement in aqueous solubility, when there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent, these are some of the hydrotropic. Then we call this phenomena to be hydrotropic solubilization phenomena. Again, you listen, when there is enhancement in aqueous solubility of a poorly water soluble drug in the presence of a large concentration of an agent, then we call this phenomena to be hydrotropic solubilization phenomena. So now here actually what we are observing, that the molecules of solid, when they come in liquid state in solution, in aqueous solution or in water, those molecules are now present in the solution to take part in hydrogen bonding and weak van der Waals forces with the molecules of solutes, and hence there is high solubility of poorly water soluble drug in hydrotropic solubilization. So this is the mechanism of dissolution or solubility enhancement in hydrotropic soluble solutions and so on and so forth. If you have any doubt or anything, please note down. At the end of the lecture, we will have question answer session. There are so many examples of hydrotropic solubilization, but time is limited. So the students, our teachers, our researchers, whosoever are interested for this PowerPoint presentation to see different examples, they can contact me. At the end of the lecture, I will give my contact number. They can associate with me by WhatsApp or email ID and so on and so forth. They can ask in future also. Now after all this, now we have understood that solids also possess solubilizing power. Now the application part of solubilizing power of solids we shall discuss. So firstly, actually I have told you that this hydrotropic solubilization is more than 100 years old concept, but no one has started its application in analysis to replace harmful organic solvent. So now this you see in various fields of analysis, titrimetry, UV analysis, HPLC, PLC, etc., etc. I will explain to you. So firstly, we will discuss eco-friendly titrimetric analysis of poorly water soluble drugs using hydrotropic solution without using organic solvent. Now, firstly, you see this example of furosemide bulk drug, assay of furosemide API. API means from the point of view of students, let me explain you. API is ectopharmaceutical ingredient, or in other words, you may say the bulk drug, furosemide. For example, 25 kg bag is there in industries to make their tablets, capsule. So first, it is analyzed. I mean, the sample, 25 kg drug sample is analyzed with how many percent of drug is there in there, whether it is 99%, 98%, and so on and so forth. So for that, assay is performed, and this is we are going to discuss the Indian pharmaceutical method. It is still official in 2022 IP, means the latest IP 2022 that also contains the same procedure, and of course the BP method is also same. What is that? Weigh accurately about 0.5 gram furosemide API, dissolve in 40 ml of DMF, which is a class 2 organic solvents, in a conical flask. You are taking 40 ml of dimethyl formamide, DMF means dimethyl formamide. In this, you are dissolving 0.5 gram of furosemide, you will get a clear solution. Then few drops of bromothiamine blue solution as indicator is used, it's added, and this solution is titrated with 0.1 molar NaOH solution from the butane. As soon as endpoint comes, we have to note down the volume of this NaOH solution consumed. Suppose this volume is x1 ml of NaOH solution in this particular titration. Then we have to carry out the blank determination. How this blank determination is carried out? You will take another conical, neat and clean conical flask. You will add 40 ml of dimethyl formamide, few drops of bromothiamine blue indicator. You will add NaOH to get again endpoint. Very small volume, 1 ml, half ml, etc. is used here to neutralize this solvent. Suppose it has taken, say, Y1 ml of NaOH. This Y1 ml has been consumed by your DMF, which has been used to dissolve your drug. Means this one Y1 ml has been consumed by your solvent itself. So this Y1 will be subtracted from X1. So X1 minus Y1. This much volume of NaOH has been consumed for your drug. Then using the factor which is given in the bottom, 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of furosemide. You can find out the drug content in your API. Okay, so this is official method. What they are going to use? They are going to use DMF, dimethyl formamide, which is a class 2 organic solvent. Now, and of course, class 2 organic solvent means suppose there was good solubility of furosemide in ethanol, then pharmacopoeia person they could have utilized ethanol for the dissolution. Furosemide is water insoluble drug, so water cannot be applied to make its solution. No, ethanol could be tried, but there is the solubility of furosemide is small, sparingly soluble, 1.7% solubility there. So because of this poor solubility in ethanol, which is a safer class 3, relatively safer than colostrum in the TMF, but ethanol could not be employed by pharmacopoeia person because of poor solubility of furosemide in ethanol. Okay, so then they have gone for colostrum organic solvent TMF, which is good solvent for dimethyl for this furosemide. So they have employed a colostrum organic solvent. These all on organic solvent, they are volatile, and due to volatility they go inside your body. When you are performing the estimation, these dimethyl formate will go in your body and all that. Anyway, what I wanted to tell you, why they have not employed ethanol, which could be a safer organic solvent than TMF. The reason is because of poor solubility. Okay. Now, so they have employed TMF. Okay. Now I will tell you that we can potentiate the solubilizing power of ethanol to act as a strong solvent for furosemide, so that you see. Now listen me first. As I have explained earlier, that 15% niacinamide solution in ethanol is good solvent for this furosemide. About the solubility is about 5%. We have discussed previously. Okay, so means good solubility of furosemide in 15% niacinamide in ethanol solution. And of course, we have seen the reason for solubility niacinamide molecules, they are being involved in hydrogen bonding and so on and so forth. Okay, now this is good solvent. So in place, what I have done, I've used 40 ml of 15% weight by volume in niacinamide solution in ethanol in place of dimethyl formate. So my solution was ethanolic solution of niacinamide 15%. In this 40 ml, now it nicely dissolves in 0.5 gram of furosemide, so you get a clear solution. Then a few drops of bromothione blue indicator were added, and NaOH was used for titration. Reading, suppose it is x2 ml of NaOH. Then blank determination. For blank determination, another conical flask, 40 ml of 15% niacinamide in ethanol solution, 2 drops of bromothione blue indicator NaOH. So very small volume is consumed. So that is suppose Y2 ml. So this Y2 ml has been consumed by your solvent system. So X2 minus Y2, this much volume of NaOH has been consumed by your drug. So using the same factor of pharmacopoeia, 1 ml is equal to 33.07 milligram of furosemide, you can find out the drug content. So this is one method. What I have done, I have made ethanol a strong solvent for furosemide, utilizing the solubilizing power of a safe solid niacinamide, which does not evaporate out. Okay, so in this way means what you can also do, anyone can do. Class 3 organic solvents can be the solvent power of class 3 organic solvents can be potentiated by use of solubilizing power of solids. Okay, to act as class 2 or class 1 organic solvent. So this is one example of potentiation of solubilizing power of a class 3 organic solvent to act as a class 2 organic solvent like DMF. Actually, what you have done, you have made 15% niacinamide ethanol solution, which is as good as dimethyl formamide. If you are using dimethyl formamide, dimethyl formamide will go inside your body. If you are using ethanolic solution of niacinamide, only the ethanol will go into your body. Ethanol, it is safer than dimethyl formamide. So anyway, in this way, any researcher, he can utilize this type of work to potentiate the solubilizing power of class 3 to act as class 2 or to act as class 1 organic solvent. Okay, so this was the potentiation of solubilizing power. Now, still better method, eco-friendly method I will discuss now, that is hydrotropic analysis. Assay of furosemide API using hydrotropic analysis. Now you see, weigh accurately about 0.5 gram furosemide API, dissolve in 40 ml of 30% weight by volume solution of sodium benzoate in a conical flask. Few drops of bromothione blue indicator added, titration with 0.1 molar NaOH. Suppose on at end point the volume consumed there of NaOH solution is, say, for example, x4 ml. Then a blank determination will be done. Another conical flask, 40 ml of 30% weight by volume sodium benzoate solution. Few drops of bromothione blue indicator, titration. Suppose reading here is Y4 ml. So this Y4 ml has been consumed by our sodium benzoate solution. So this will be subtracted from X4. So X4 minus Y4, this much volume of NaOH has been consumed by our drug using the same factor of pharmacopoeia. 1 ml of 0.1 molar NaOH is equivalent to 33.07 milligram of glutamide. You can find out the drug content. Okay, so in this way, what is the beauty of this hydrotropic method or green analytical technique? This is that without the use of organic solvent, without the use of ethanol, without the use of DMF, we are going to perform the titrated analysis just by utilizing aqueous solution of sodium benzoate. Okay, so here sodium benzoate does not evaporate out now. And about the cost, 1 liter of 30% weight by volume solution of sodium benzoate can be obtained just merely in rupees 40. Rupees 40 per liter is the cost of 30% weight by volume sodium benzoate solution in water. Otherwise, the cost of ethanol, methanol, DMF, etc. is 200 rupees, 250 rupees per liter, and so on and so forth. So this is actually in this particular method, what we are doing here, we are replacing dimethyl formamide, which is a class 2 organic solvent, by safe use of a economic sodium benzoate. You are making a concentrated solution of sodium benzoate in water, and that is being used as solvent system to carry out this titrated analysis. And of course, there is no interference in this. One more thing, let me tell you, Ghaziabad IPC lab, Indian Pharmacopoeia Commission lab is there in Ghaziabad, and so this work there also in my presence, the analytical camp staff IPC lab, they performed the estimation by this hydrotropic method as well as by their pharmacopoeia method. The same results were there. One more example is that of naproxen. Anyway, so here there is no question of any doubt, and if you have any doubt, please raise your question at the end of the lecture. Okay, so in this way, we are utilizing hydrotropic solution to replace organic solvent. Similarly, now on the same basis, flurbiprofen API, here there is involvement of ethanol in IPBP method. This ethanol has been replaced in the same way by sodium benzoate solution. Okay. Similarly, naproxen API, SA, IPBP method utilizes methanol, class 2 organic solvent. This methanol has been replaced by sodium benzoate solution in the same way. Actually, here what is happening? Actually, we are utilizing the solubilizing power of solids, because the molecules of sodium benzoate, they are available in liquid state for hydrogen bonding and for forces. The molecules of these insoluble drugs. That's why you are getting the solubility and all that. Salicylic acid API SA method, IPBP method uses ethanol, class 3 organic solvent ethanol, but this organic solvent has been replaced by sodium citrate solution. Sodium citrate solution is very good, has got very good solubilizing power for salicylic acid. So sodium citrate solution has been applied to replace ethanol, and of course the cost of sodium citrate is also less. Ketoprofen API ethanol is used. Sodium benzoate has been used to replace it. Ibuprofen API ethanol is used in IPBP method. It has been replaced by sodium benzoate solution in the same way. Now I will discuss the assay of ibuprofen tablets by IPBP method. Of course, IP 2022. That actually I have to see, but perhaps it should be the same method, I think. Anyway, what happens in this 20 tablets are weighed, average weight is determined, and weigh accurately the powder equivalent to 0.5 gram of ibuprofen. Then extraction with chloroform, 3 times extraction is there. Then the chloroform extracts, they are solutions, they are mixed, and then they are allowed to remove the chloroform and air current. Then when you get a residue, that is dissolved in 100 ml of ethanol, and then titration is performed with 0.1 molar NaOH solution in monthly as indicator. Carry out the blank determination. Of course, in blank determination, you will use 100 ml of ethanol. Anyway, then each ml of 0.1 molar NaOH is equivalent to this much gram of ibuprofen. So based on this, you can find out the drug content of your tablet. So the basic things here, requirement is that of chloroform, class 2 organic solvent, and ethanol, which is the class 3 organic solvent. So here 2 organic solvents are involved in pharmacopoeia method. Now you will see Without any organic solvent, you can perform the trichromatic analysis of tablet. In this particular method, weigh the tablet powder equivalent to ibuprofen. Shake briskly for 10 minutes with 100 ml of 30% sodium benzoate solution. So during this shaking, whatever the ibuprofen is present in the tablet powder, it is being dissolved by sodium benzoate solution. Then titration is done with 0.1 molar NaOH using naphthalene as indicator. Filling determination is carried out using 100 ml of 30% weight sodium benzoate solution. Then after correction, 1 ml of NaOH is equivalent to this much gram of ibuprofen. You can find the surface content. The beauty of this method is that neither you are using chloroform nor you are using ethanol. Just you are using aqueous solution of sodium benzoate, which is the cost I have told you, that is rupees 40 per liter or 30% sodium benzoate solution. Okay, that has replaced chloroform, that has replaced ethanol. So without organic solvent, we are performing the trichromatic analysis. Similarly, these are examples. Coming to the UV spectrophotometric estimation methods of poorly water soluble drug tablet, etc. capsule without organic solvents, hydrotropic method. So firstly, we see the example of pharmacopoeia method. IP 2022 should also be like this only. Of course, this is from 2018. Assay of indazole tablets with tablet powder equivalent to 0.15 gram of indazole. That is taken in a 100 ml volumetric flask. 20 ml of methanol is added, which is a class 2 organic solvent, and shaking is done. During this shaking, the indazole present in the tablet powder goes in the solution with the help of methanol. Of course, indazole is a water soluble drug. That's why IP has utilized methanol. Okay. Then after shaking with 20 ml of methanol for sufficient time, now then volume is made up to 100 ml with methanol. Then filtration is done to remove insoluble excipient. From filtrate, 10 ml is taken and it is diluted up to 100 ml with methanol. This IP method. Then again you take 10 ml from this solution and dilute it up to 100 ml with methanol. And the absorbance of this particular solution is noted at 310 nm, 310 nm against methanol reagent blank. Okay, because here your solvent is methanol, so you will keep in the reference of it also methanol is there. You have noted the absorbance at 310 nm. Then calculate the content of indazole taking 356 as the specific absorbance at 310 nm. This 356 is specific absorbance, or in other words, we say E1% 1 centimeter value is there. So using this factor, you can find out the drug content of your tablet. What you have done, you have utilized methanol, which is a class 2 organic solvent. Okay. Now, without methanol, also we can perform the UV analysis, means hydrotropic method. Assay of indazole tablet, weight tablet powder equivalent to 50 milligram of indazole. Add 20 ml of 30% aqueous sodium benzoate solution and shake for 10 minutes in a 25 ml volumetric flask. So what you have done, you have used 25 ml volumetric flask, 20 ml of 30% sodium benzoate solution, and tablet powder equivalent to 50 milligram indazole you have taken, and you have shaken it for 10 minutes briskly. During this shaking, due to hydrotropic solubilization, the indazole goes in solution. Then shaking, then make the volume up to 25 ml with distilled water, and then it is filtered. It is filtered to remove insoluble excipient. Dilute 1 ml filtrate up to 100 ml with distilled water, and then measure the absorbance at 318 nm of this reagent blend. There are two things important. Number one, here the wavelength, peak wavelength is 318 nm. In case of methanol, it was 310 nm. Due to change in solvent, methanol, here water, there is shifting of peak. That happens. That may happen due to change in solvent. No problem. So at 318 nm, you note down the absorbance of this solution against reagent blank. How this reagent blank is made from the point of view of students, let me explain. Reagent blank means reagent blank is such a solution which contains same, you may say, same things or same materials which are present together with the drug. For example, you see here, firstly, again we are considering this thing: 50 milligram tendazole tablet powder, 20 ml, 30% aqueous solution, shaking, then making up the volume 25 ml. So 50 milligram tendazole, they are present in 25 ml solution, means 2 milligram per ml. 50 milligram per 25 ml means 2 milligram per ml. 2 milligram per ml means 2000 microgram per ml. 2000 microgram per ml is the concentration in the filtrate. And now this 1 ml of filtrate is diluted to 100 ml with water, means 100 times dilution. So 2000 divided by 100 means 20 microgram per ml solution is there, this one. So in this particular solution, drug is 20 gram per ml together with sodium benzoate. Now we will make reagent blank in this way. You will take again a 25 ml volumetric flask, another means neat and clean. 20 ml of 30% sodium benzoate solution you will transfer in this. Volume is made up to 25 ml with water. Then from this solution 1 ml you will take and dilute it up to 100 ml with water. So this is the reagent blank because this solution contains the same concentration of sodium benzoate which is present together with your drug 20 mg per ml. So this reagent blank solution will be kept in the reference cuvette, and in the sample cuvette you will put the drug solution containing sodium benzoate. Since in both cuvettes the same concentration of sodium benzoate is there, so they neutralize the effect of each other. Whatever the absorbance you are putting at 318 nm, that will be your drug only. Okay. So now what you have done, you have noted down the absorbance against reagent blank. Now you want to compute the results to find out the drug concentration. So what you can do? You can do in two ways. Number one, calculate the content from the absorbance obtained by repeating the whole procedure using 50 milligram tendazole reference substance. RS means reference substance in case of tablet powder. Means you will have to do it this way. You will take a drug, pure drug sample, authentic sample of tendazole, means it is not a tablet powder. The samples which we obtain from the companies, and on that it is written it contains 99.34% of drug and 98.79% drug. So based on this, you will take 50 milligram of pure drug, 25 ml volumetric flask, 20 ml sodium benzoate solution. It will be dissolved and up to 25 ml with water. Again 1 ml diluted up to 100 ml with water, and you note down the absorbance again the same reagent blank which you have prepared, and you comparing these two absorbance you will find out the drug content of your tablet. Otherwise you can make a calibration curve of this tendazole, and then that calibration curve can be employed to compute the results to find out the drug content of your tablets. How? For this, you can use 5, 10, 15, 20, 25 mg per ml solutions, standard solutions, and same will be the respective reagent blank. 5, 5, 10, 10, like this. You will have to mix respective reagent blanks. Keeping reagent blanks, you will note down the absorbance at 318 nm. Using these 5 absorbance, 5, 10, 15, 20, 25 per ml, you can plot a calibration curve using the same this regression equation. You can find out the drug content of your tablet. In simple way, what we have done, we have utilized sodium benzoate solution. Further dilutions were with water, very cheap method. Number one. Number two, there is no involvement of any. Means you say sodium benzoate does not evaporate out; it will not go in your body. Okay, like this. And what you have done, you have replaced methanol, which is a class 2 organic solvent. Okay, in pharmaceutical method, you are being exposed with the vapors of methanol, but here there is no exposure for organic solvent. So without the organic solvent, you are able to perform the UV analysis of tendazole tablet just by using the hydrotropic solubilization technique, green chemistry, which you may say. You may have so many questions in your mind. Please note down at the end of the lecture. We have discussion, question answer session will be there. In the same way, naproxen tablets, they have been estimated using sodium benzoate. One more thing, let me tell you. One more thing. It is important. Sodium benzoate does not interfere above 292 nm. Above 292 nm, sodium benzoate does not interfere in UV analysis. Because if we want to see what you say, the cutoff point of sodium benzoate solution is 292. Above this, there is no problem. For example, here you are estimating it at 318 nm, which is quite away from 292. So there is no interference in UV analysis using sodium benzoate. So always when you use sodium benzoate, you will have to use for such drugs which have their peak above 292 nm. For example, you see, in case of naproxen tablet, they have been estimated at 331 nm using sodium benzoate. Indomethacin, 320 nm. Diazepam, 24 nm. So in this way, you are seeing that methanol, class 2 organic solvent, can nicely be replaced by hydrotropic solution and mixed hydrotropic solution. Now you may say, suppose your drug has got peak before 290, what to do? So anyway, two more hydrotropic agent, two more tablets I am going to discuss. They are atenolol tablet and dichloromethane sodium tablet. Atenolol tablets, IPPP method it is same, methanol is used. Dichloromethane sodium also tablets, methanol is used. Now this methanol will be replaced by urea solution. In the same way, just like sodium benzoate solution, urea solution. Urea cutoff point is 240 nm. Above 240 nm, urea does not interfere. Sodium acetate does not interfere above 240 nm. Sodium citrate does not interfere above 240 nm. Okay, so urea solution, concentrated hydrotropic solution, has been used in case of atenolol tablets to estimate atenolol at 275 nm. 275 nm is quite away from 240 nm. There is no UV interference in atenolol tablets. Similarly, dichloromethane sodium is estimated at 276 nm. Using urea, the methanol has been replaced in this case also. Now coming to TLC directly now. Firstly, you see the reference. Always you will find the references of the published paper. They all are available on Google search. Free of cost, you can find out it's a PDF. Now, so this is the work employment of hydrotropic and mixed hydrotropic solutions as mobile phase to carry out TLC precluding the use of organic solvent. Now, what has been done here? The M Pharm student, 3 M Pharm students were there in this team, and they carried out the work, TLC work. 9 water-soluble drugs were selected. Furfuronal, hydrochloride, guaifenesin, up to losartan, potassium. These 9 water-soluble drugs were used in this TLC. Chromatography. For making the spot on the TLC plate of silica gel G, 2% aqueous solutions of the drugs were used to put the spot. For example, losartan, potassium, 2% aqueous solution. Capillary was used to put the spot, then the spot was dried, and after drying means removal of water. Now these plates were kept in different blends, to develop the plate, and after development of the plate, now these plates were heated at about 60-70 degrees centigrade to room water for their drying, and then spot identification was done with the help of iodine chamber. So, for example, now you see here blend 1, aqueous solution, hydrotropic is in sodium benzoate and sodium acetate, 5%. So, total is 10% solution. So, this solution was used as mobile phase to carry out the TLC. This solution does not contain any organic solvent. Otherwise, up to this time, whatever the TLC you will see from the literature, up to this time, you will find that at least one organic solvent is there. Sometimes 1, 2, 3, they may be there. Okay. Now I will tell you, I told the student to make 8 blends they have prepared. Blend 1, 2, 3, 4, 5, 6, 7. And one more blend is there. So blend 2 is sodium benzoate plus niacinamide. So blend 3, sodium benzoate plus sodium citrate. Blend 4 is 10% sodium benzoate alone. This is hydrotropic solution. These others were mixed hydrotropic solution. 5 sodium acetate niacinamide, sodium citrate like this. So for each drug, 8 blends were employed, and then the RF values were calculated. I told the students that they will select such a blend which gives a spot without peeling effect. So, okay, in case of propanol hydrochloride, 8th blend, this is the 8th blend, 7.5% niacinamide and 7.5% benzoate. This gives the RF value 0.8 and the spot was without peeling effect. Other 7 blends, they were not good for this propanol hydrochloride. In case of guaifenesin drug, blend 1, 2, 3, 4, and 7, they were found good, gave good spot without peeling effect, RF values are there. In case of ciprofloxacin hydrochloride, only blend 6 was found good. Vitamin B6 hydrochloride 7 blend. Lidocaine, so many blends were found suitable like this. Now you see the beauty of this method. You see if we discuss the IP procedure for 5 drugs, IP procedure. So ciprofloxacin hydrochloride TLC improved the use of involve the use of dichloromethane, methanol, and of course acetonitrile. 3 organic solvents are being involved. All are from class 2 organic solvent category. Class 2. Guaifenesin, carbon tetrachloride, which is class 1, and ethanol class 3 like this. So in all these, if you see at least one organic solvent is there. And in new procedure of hydrotropic method, what you are utilizing? Yes, we are utilizing the solubilizing power of hydrotropic agent to carry out the TLC. Now you listen one sentence from me that for each and every compound, whether compound is water soluble, whether the compound is water soluble, for all compounds, failure chromatography can be performed using hydrotropic solutions or mixed hydrotropic solutions. If your compound is water soluble, smaller concentrations of hydrotropic agent is sufficient to carry out the TLC. If your drug is insoluble, then higher concentrations like 25%, 30% blend, they will be utilized to carry out the failure chromatography. But definitely you can carry out the failure chromatography of all compounds using hydrotropic solutions or hydrotropic solutions without the use of harmful organic solvent. And what I want to tell you that in your college also you can do this type of work to our third year, final year student. Very simple work is there. Whatever the drugs you are having, for all drugs you can perform the TLC using hydrotropic solutions or mixed hydrotropic solutions without the involvement of organic solvent. Always in all the pharmacy colleges there are certain students who want to do some creative work or some new research work. So they can be given this work very means 3-4 days. A small paper, research paper is ready that can be presented in any conferences, and after presentation in conferences they can be published as well. So the name of the student, name of teacher, name of the institute, these all things are there. So such type, and of course there is main thing is the objective is good. What is the objective? That you are giving some you must say information to the researchers of this universe that without the use of organic solvent you will perform the failure chromatography. Why do we want to replace organic solvent? We have discussed that otherwise the organic solvent they give different, you will say the ill effects to the human being and all that. Now coming to the HPLC. This is the published paper. Here this work has been done by Remy SL Madam. She is in Kerala. She is assistant professor. She has done PhD work on hydrotropic. So this novel reverse phase HPLC method development and validation of cefixime in bulk and its doses formed by using hydrotropic solution is mobile phase. So Remy Madam has done this, carry out this work, and of course the published published paper is available online. It is on Google search. You can find the complete PDF on Google search. What she has used, Remy Madam has used as mobile phase in this particular case of cefixime tablet, 6% weight by volume aqueous solution of sodium acetate, adjusting the pH to 6.2 with acetic acid. 6% sodium acetate solution is slightly alkaline. Its pH is about 8 or 8.5. So these alkaline solutions, they give harm. They are harmful for the life of the column. So what she has done, she has used acetic acid to bring down the pH to slightly acidic side is 6.2, and this aqueous solution without any organic solvent was used as mobile phase to carry out the reverse phase HPLC. Of course, you may say so many validation parameters could not be performed in this first paper, but in this second paper of Remy madam, she has done a lot of work and so many validation parameters she has carried out. And what she has done, this is for a novel, eco-friendly, cost-effective mobile phase for HPLC, simultaneous estimation of parasitic hypochlorite sodium in bulk and pharmaceutical formulation by reverse phase HPLC using hydrotropic solution as mobile phase. So here the 5% urea solution was used as mobile phase to carry out this reverse phase HPLC. 5% aqueous solution of urea. No any other organic solvent, no methanol, no acetonitrile, etc. And without using any organic solvent, this work was performed. These tablets containing 2 drugs, paracetamol and dichloromethazonium. The PDF of this complete paper is also there on Google search. Now you listen one sentence from me. Those who are interested to carry out reverse phase HPLC of compounds using hydrotropic solution or mixed hydrotropic solution, they should select water soluble compounds first thing. They should forget about the water soluble drug though. They will select water soluble drug for each and every water soluble compound or water soluble drugs. Reverse phase is possible by the use of hydrotropic solutions or mixed hydrotropic solutions. Okay, so those who want to carry out this work, they should select any water soluble compound, any water soluble drug, and the reverse phase HPLC can be performed using, say for example, 2% sodium iodide solution, 3% sodium iodide solution, or 2% sodium iodide plus 2% sodium citrate, or like this. So these smaller concentration solutions can be used to carry out the reverse phase HPLC of water soluble compounds. Mixed hydrotropic solubilization, solubility of furosemide. Now here, this is why mixed hydrotropy has been started. Of course, this has been started in the year 2008. I have told you that hydrotropic solubilization is about 100 years old concept. No one has used mixed hydrotropy before 2008, and this is the, you may say this is the work carried out by M. student. It is Germany here, and why mixed hydrotropy has been started by us. The reason is that single hydrotropy cannot be used successfully to make marketable formulations. For example, so many researchers from 100 years, they are carrying out the research work, they are making intramuscular injection using 30% sodium solution or so on so forth. Because of the large concentration of hydrotropic agent, because of its toxicity of this hydrotropic agent, the concept has not been much in the formulation, single hydrotropic, no. From 100 years, you will not find, hardly you will find any, say, pharmaceutical product based on hydrotropic solubilization. Reason is this, that 30% sodium iodide cannot be used in intramuscular injection, etc. So let me explain you this thing, then we will come again on this slide. Now you see, with this slide I can explain you why mixed hydrotropic solubilization has been started. The reason is to solve the problem of toxicity issue of this hydrotropic agent. Okay, now you see, this is a small table containing excipients in the concentrations mentioned, for example 10% or 5%. These concentrations of these additives can be employed in aqueous intramuscular injections. This list has been taken from Inactive Ingredient Guide 2019. It is 2019. It is a book which is followed by the pharmaceutical manufacturer. The pharmaceutical manufacturer, they see that how many, what is the concentration of any additive which can be employed in formulation. So from that book, Inactive Ingredient Guide book, these ingredients I have brought for you. These all are additives, the so-called additives used in intramuscular injections. For example, alcohol is safe in 10%, sodium citrate is safe in 10%, and so on and so forth. Now from this list, which they are safe means from the point of view of toxicity. Now you see number 13, sodium benzoate 10%. In this inactive ingredient guide, you will not find any concentration beyond this 10% which could be employed for aqueous intramuscular injection. Means suppose a researcher has made intramuscular injection using 30% sodium benzoate solution, that cannot be marketed in the formulation. 30%. because you may say that due to toxicity of sodium benzoate, but up to 10% sodium benzoate can be employed in intramuscular injection. Okay. Similarly, you see number 2, sodium citrate, 10% can be employed safely. If you see number 8, sodium acetate, 10% can be employed safely. Now, if we mix these 3 hydrotropic agents, sodium benzoate, sodium acetate, sodium citrate, 10, 10, 10, 30% solution is ready with hydrotropic solution, and there are several poorly buttered soluble drugs solvent is enhanced in this solution. So, for those drugs, the intramuscular injections be developed which can be marketed. Mixed hydrotropy can solve the problem of toxicity issue, and hence the marketable formulations can be developed. In Egypt, there is scientist Dr. Maheshwari, who has seen my research paper, and he has started mixed hydrotrophic solubilization to make the marketable formulation. He is there in Egypt, and he is still using mixed hydrotrophic solubilization. So this was regarding mixed hydrotrophy. Now something about the mixed solvency concept. Mixed solvency concept I have started in the year 2009. Now there are 2 parameters in this mixed solvency concept. Number 1 parameter of mixed solvency concept says that each and everything present in this universe has got solubilizing power. Each and every molecule in liquid state is having solubilizing power. Okay, number 2, since all the things have got solubilizing power, so we can utilize the solubilizing power of additives to enhance the solubility. How? This mixed solvency concept second parameter, now I will explain it. Using the second parameter of mixed solvency concept, you can make innumerable safe solvent system to make the aqueous intramuscular injection. For example, number 1 blend or solvent system, you can make number 1 by ethanol, and you see in this table 10%. Total became 30%, 3 ingredient, 10, 10, 10%. This is 1 blend. Now you can you can replace arginine using histidine. Another blend is ready. So just by permutation combination from this small list, you can make innumerable safe solvent system, and they will have different solubilities of your drug. So what you are going to add up? You are going to use the solubilizing power of so-called additives, which are used safely in your intramuscular injection, because now you know that each and everything has got solubilizing power. So maybe that for your drug, that additive may have got good solubilizing power. So in this way, you can develop innumerable safe solvent system. Otherwise, today if you see in the pharmaceutical companies, they have limited safe solvent system, water, ethanol, propylene glycol, glycerin, EG400, etc., trains and all that. But when they are incapable of enhancing the solubility, now they are handicapped, and that handicappedness can be solved. This problem of handicappedness can be solved using mixed solvency concept second parameter. That if you prepare a concentrated solution using safe concentrations of several additives, then this concentrated solution may enhance the solubility of your drug, and you can develop aqueous intramuscular injection. This is for aqueous intramuscular oily solution and so on and so forth. Coming in water at room temperature by Hitesh Jagwani. This is the solubility 0.008%. I told him to use 4 hydrotropic agents: urea, sodium acetate, sodium benzoate, sodium citrate. 40% was kept constant. The solubilities you are seeing on the right hand column, and the maximum solubility was in case of sodium benzoate, that was 2.157%. Then I told it is in different ratios of these 4 hydrotropic agents, keeping 40% concentration constant. Then he checked the solubility of fusimide in different mixed hydrotropic solutions, and solubility studies were done. Out of those about 15-20 blends, the 3 blends are before you, where we are having very synergistic solubilizing action due to mixed hydrotropy. Number 15% urea. So total became 40%. In this solution, the solubility of drug was 4.2%, which is nearly double than that of sodium benzoate, which was the maximum. And 8 also, the synergistic solubilization power was there. Mixed hydrotropic can solve the problem of toxicity, and you can develop the marketable formulations. Now, second parameter of this mixed solvency concept, let me explain again. Blend, the pH was found 7 of which blend? A blend, aqueous blend containing 5% sodium benzoate, 5% sodium caprylic, 5% sodium citrate, 5% full summer. All these are four solids. These are four solids by 5%. Total became 20% aqueous solution. In this solution, the pH of the solution is neutral. There is 7. In this solution, mixed solvent system, the solubility of several poorly water soluble drugs was checked by me. Out of those, I am giving the example of 2. In case of fusamide solubility, 35 milligram per ml was found in this particular blend. Okay, otherwise in water, it was not even 1 milligram per ml. At least 35-fold solubility enhancement is there. What is the reason for this? Again, you see the sodium benzoate, caprylic, citrate, or full these molecules are in liquid mixed solvent system. The molecules are in liquid state, and these molecules are involved in hydrogen bonding and weak bonding forces with the molecules of fusamide for its solubility enhancement. Okay, so this is the case. So actually, what you are getting the solubilizing of power of these solids to increase the solubility of fusamide. Suppose you want to make a dry powder injection for reconstitution of this fusamide, what you can do? 35 milligram per ml. So 20 milligram is the tablet dose. In the marketed formulation, they contain 20 milligram per tablet or 40 milligram per tablet of fusamide. So 20 milligram per ml injection can be developed using this mixed solvent system. How? You see, 35 milligram per ml is the solubility, so 20 milligram per ml solution can nicely be made using contains 5 gram is 5,000 milligram in 100 ml, 5,000 milligram in 100 ml, 10 ml, 500 milligram, 1 ml, 50 milligram. So 50 milligram sodium benzoate, 50 milligram sodium caprylic, 50 milligram sodium citrate, 50 milligram Pulak summer 407 and 1 ml of solution. And when you will add 20 milligram of fusamide in this, you will get a clear solution because of mixed solvency concept. So if you want to develop it's a dry dosage form, dry powder injection for reconstitution, while 50 milligram all have been shipped through fine seed, and while they are being kept for 1.5 year, 2 years, the life is, means in dry condition life is more. Whenever it is required, 1 ml water for injection is added, reconstituted, you will clear solution injected like this. So particularly this concept is very useful in cases of those drugs, water soluble drugs, which are injection. What you can do to make their reconstituted aqueous solutions, you can utilize the solubilizing power of solids. You are not using any solvent system. You are using solid solubilizing power. These solids will be kept in the boil together with your drug. After means the shelf life of dry dosage form between 1.5 years, 2 years when transport. At the time of need, water will be added, reconstituted, you will get solution of life. So in this way, dry dosage form. Similarly, you can utilize the concept to make dry syrup for reconstitution, which will market fixing suspension is there, powder is there, you bring water is added, volume is made, and then of course you reconstitute, you get a suspension. But suppose you use solid solubilizer, safe additives, and if they can give you solution after reconstitution, of course that will be consumed in 7 days as in case of suspension. But the thing is, the solution has got more viability than suspension. So to act in the same way, to the same extent, you will have to reduce the amount of drug. And suppose there is like that. So anyway, of course, such type of work they are very useful in industry. Now I will narrate the use of mixed solvency concept. Of course, time is limited, so in briefly I would say which type of MPAR project work have been done in SGSITS Indore under my guidance. So now I am discussing those students or teachers or researchers who are interested. I can send the soft copy of this MPAR project thesis to you to see the step by step how will you proceed to get such type of work done. So like this, so do not hesitate. If you need, you can ask me, because from published paper alone sometimes it is difficult to carry out the research work. So you can ask for soft copy of MPAR thesis. So this is one work MPAR project work has been done. Published paper references here. Dry powder injection for reconstitution of poorly water soluble drug can be certain selected for 1 ml injection was this was the project MPAR project. The dose of candy certain selected drug is 8 mg, which is water soluble drug. Sodium caprolate 100 mg, sodium benzoate 50 mg, sodium acetate 50 mg. These were kept in together with 8 mg of drug in a vial. Solids. Mixed solvency concept can be used to make solid dispersion. 2 for fast dissolution of poorly water soluble drug. So here the example is that MPAR project is that of torsemide drug, water soluble drug. Torsemide 2.5 gram was dissolved with the help of aqueous solution containing these 4 solids. Sodium citrate 1.25 gram, sodium acetate 1.25 gram, with a cyclotation 2.5 gram, sodium caprolate 5 gram. These 4 solids were firstly dissolved in a small quantity of water. Now this is made a mixed solvent system, and then in this solvent system, torsemide 2.5 gram was dissolved, you get a clear solution. After that, water was evaporated out by heating by strain, and when semi-solid was obtained, it was kept in plates and oven at about 60-70 degrees to remove the water, and after drying, it was powdered and washed to fine sieve. So this is a solid dispersion of torsemide for fast dissolution. So MPAR thesis there, you can ask for that. Liquid solid system, poorly water soluble drugs, they can be developed with the help of solid system. Solubility of pyroxicam and propylene glycol is less than 5 mg per ml, poor solubility. Okay, so for example, the dose of pyroxicam when marketed tablet is 20 mg. About 4 ml of propylene glycol is nearly 4 gram. This is liquid solution. This will be absorbed by about 60 grams. So you cannot make it tablet, you cannot make it free flowing to make tablet or capsule. No, because in liquid solid system you select a non-aqueous solvent, just like in this case propylene glycol. Now the improvement or drug loading was improved with the help of mixed solvent system, and propylene glycol was made a strong solvent with the help of sodium caprolate and sodium acetate. 10% sodium acetate, 10% sodium caprolate when they were dissolved in propylene glycol. The molecules of these 2 solids are in liquid state now, of course, and the solubility of pyroxicam in this particular mixed solvent blend about 120 mg per ml. 120 mg per ml. 120 divided by 24-fold enhancement in solubility there, as a result of solubilizing power of these 2 solids, sodium acetate and sodium caprolate. Okay, now what you can do, you can develop it's a liquid solid system. How? Suppose you take 120 mg per ml is the solubility. Suppose you take it, assume it to be 100 mg per ml. Means 100 mg drug can be present in 1 ml of the solution, this mixed solvent system. So for 20 mg, require 0.2 ml, 0.2 ml, but 0.2 ml means nearly 200 mg. And now this solution containing drug will be absorbed with the help of about 600 mg of high cellulose to make it free flowing. And then this free flowing powder may be kept in capsule or it may be converted into tablet and so on. What you have done, you have utilized the solubilizing power of solids to improve drug loading, so that in the small volume of solution you solution, and then it can be absorbed to make it a solid system. So this is MPAR project. If you want, I can send the soft copy of thesis. Similarly, indomethacin. Previously it was pyroxicam. Here this is on indomethacin. No, this is dry powder. It was candicertan selected. Sorry, and now this is indomethacin. Then this I have discussed. Similarly, vaginal film, the size of film could be reduced by increasing or improving the drug loading using mixed solvency concept. Here, the drug selected by student was betonadazole. Okay, and by safe additive, the drug loading was improved. In case of ACDDS, also the drug loading can be improved. Drug loading in oral film was done using this drug, and of course, this is the published paper reference. Okay, in the same way, by improving the drug loading, the size of oral film was reduced. Here also, in this case, also again, this is also on oral film. The drug selected was amlodipine, and of course, drug here. Now, since the time is less, so let me explain. First thing is solids could be implied for the extraction also, up to, of course, in liquid state when the molecules were in liquid state. So here you can see the extraction of active constituent using solvent action of solids. Reference of published paper. 3 M4 students. No, they were 5 students. They have utilized. They have done the work on this, and the topic title was eco-friendly extraction using solids in novel application of mixed solvency concept. Published paper reference is available online, PDF is available online. Now, what was done? Let me explain you. Now here, we have selected sesame oil as the active constituent, which is found in sesame seed powder. So the solubility of sesame oil was checked in, say, for example, melted thymol. Thymol is solid at room temperature. Its melting point is about 50 degrees centigrade. So 1 gram phenol, this thymol was kept in test tube, 1 gram water bar at 50 degrees centigrade. We have clear colorless melted thymol liquid, means the molecules of thymol are in liquid state. So clear colorless melted thymol liquid, 0.1 ml sesame oil dissolved, 0.1 ml, 0.1 ml, more than 1 ml of sesame oil, 1 gram melted thymol is very good solubility of sesame oil in melted thymol. Now, then we have tried the extraction of sesame oil from sesame seed powder. How it was done? 3 grams sesame seed powder containing sesame oil, and because it contains sesame oil, so 3 grams sesame seed powder in a test tube, 9 gram, 3 times more, 9 gram thymol test tube, water bar at about 50 degrees centigrade, thymol was melted. Then shaking was done, 30 minutes shaking, heating, then shaking, heating, like this. In melted condition of thymol, 30 minutes shaking was done. During this shaking, melted thymol dissolved the sesame oil present in the sesame seed powder, then straining through cotton, through cloth. The strained liquid containing melted thymol containing dissolved sesame oil was kept in, say, China dish, etc., and it was kept in oven in about 1 hour, and remaining was sesame oil. Remaining was sesame oil. There may be traces of thymol in that, no problem. But what you have done? We have utilized the solubilizing power of a melted solid thymol. Similarly, melted menthol, good solvent for sesame oil, 3 grams sesame seed powder, 9 grams menthol, water bath for 45 degree centigrade melting point, and the same way like this. At room temperature, ethanol containing 50% beta-aluminum thymol. This solution is a strong solution for sesame oil. It was implied for its extraction. How the extraction was done? 3 grams sesame seed powder, 9 ml of this solution, 50% thymol and ethanol, shaking for 30 minutes. During this shaking, this solution extracted out or dissolved sesame oil which are present in the sesame seed powder. Filtration contains ethanol thiamol and sesamide was kept in oven at about 70 degrees centigrade. All ethanol, thiamol, they were removed, giving you the sesamide like this. So anyway, these are just to show the researchers of this universe that of course so many things are there, but those who are interested for this, they can contact me. We can decide what to do, how to utilize this solids and so on and so forth. But only thing to potentiate the solubilizing power of glass. Manufacturers of these oils, sesame oil manufacturers, what do? They utilize either hexane. Hexane is good solvent for sesame oil. Ethanol they could employ, but ethanol could not be employed due to poor solubility of sesame oil. So ethanol, which is a class 3 safe or organic solvent, could not be employed alone to extract out the sesame oil from the sesame seed powder. Okay. So what they have done, either they use hexane, and after extraction, the hexane is evaporated out, removed means, and there may be traces of hexane which are hazard, okay, to our health. Traces of hexane in your oil. Sometimes to reduce this contamination of hexane, sometimes they potentiate the solubilizing power of ethanol by mixing ethanol plus hexane. This blend is used for extraction. After evaporation or removal of ethanol and hexane, you get the oil, but that oil may be contaminated with ethanol, and of course the traces of hexane, they may be there. So now here, of course, the traces of hexane will be less in this case. But ethanol traces, they are not so harmful as are the sesame oil. These hexane traces are there. Okay. Now, as they have implied mixing of ethanol and hexane, I will tell you how can you potentiate the solubilization or sesame oil. We have made 50% thiamol in it. These solutions are used for what you have done. Ethanol containing 50% thiamol, strong solvent for sesame oil, just like hexane. Now, when you will extract with this thiamol ethanol, after removal of thiamol and ethanol, you will have traces of thiamol and ethanol. So thiamol has replaced the traces of thiamol. They have replaced the traces of hexane, which is safer because you take this thiamol and ajwain and all that, whatever we eat. Anyway, this is a simple thing, but what I want to tell you is solids can also be implied for their solubilizing power for the extraction of active constituent. So many things are there. If you have any questions, you please ask. Now, this is the information, important information. Eco-friendly lecture series 1 means I made 7 YouTube videos of about 40 to 45 minutes duration. So this is number 1. If you put these words, eco-friendly lecture series number 1, you will have this particular topic: eco-friendly and economic UV spectrophotometric analysis of polywater sulfur drugs by application of hydrotropic mixed solvency concept without the involvement of molecular solvent. Number 2, if you put this will be analysis. Those who want to carry out this diametric analysis, they can see this one. Number 3 is for mixed solvency concept. Each and every substance, whether gas, liquid, or solid present in this universe has got solubilizing power, mixed solvency concept. So those who want to learn more about the mixed solvency concept, number 8. Number 4 is for TLC. If you want to carry out the TLC of compounds using hydrotropic solutions, etc., you can see this one. Number 5, you put this is for reverse phase. Number 6, you put this is for dry powder injection for reconstitution. Still, after this also, I told you that you can contact me if you are a student, teacher, or researcher. You can contact me by phone, etc. I can help you in future. I am saying, okay, these things are also helpful to you, but then also you can contact me if you want. Number from the books, you will find a very less number of eutectic liquid ethanol. There's menthol, thiamol, menthol, camphor, menthol, thiamol, or aspirin, or something like that. These phenol and all that. But this is an art to develop a large number of eutectic liquids can be developed using this concept, mixed solvency concept, which you will see from this. And of course, for what purpose you want to develop innumerable eutectic liquids, for extraction, for synthesis, for analysis, for corporation, etc. Okay, now coming directly to the end. Of course, now this is my WhatsApp number. Those who are interested, they can note down 940662197. Email ID is also there. So those who are interested for this, they can contact me. And now the session is open for the questions. I shall be happy to. इसको कैसे करते हैं? Control. I shall be happy to. तो हम escape करते हैं. Okay. और इसको minimize कर सकते हैं.
Participants may ask questions.
Now the question answers.
Thank you, sir, for sharing your thoughts and enlighten our delegates. It's time to present certificate to our eminent speaker as token of gratitude. As it's a virtual lecture, so I request Dr. Rajnikant Panik sir to kindly display the certificate to our speaker as well as delegates. Dr. Rajnikant Panik sir. Sir, kindly display the certificate.
Already displayed. Is it displayed?
Sir, it's not visible.
It has been full screen. No, ma'am, it is visible.
No, sir, it's not visible.
No, sir, it's not yet visible.
Something technical issue. Already it has been shared. It's been shared, but not been displayed. Now checking.
ऐसा करिए.
Yes, it's presenting now. Yes, sir, it's visible
Yes.
now.
Thank you.
Thank you,
Thank
sir.
you, sir.
Now I would like to invite Dr. Ravindra Kumar Pandey, Principal, Columbia Institute of Pharmacy, to propose vote of thanks.
Jai Shri Krishna, sir.
Jai Shri Krishna. Jai Shri Krishna.
On behalf of IPGA Chhattisgarh branch and our college whole fraternity, I sincerely thank you. Thank you very much for this informative lecture. And as we all know, he is an eminent speaker and well known for its mixed solvency concept. And once again, I would like to thank all of you for becoming a part of the program. Thank you. Thank you very much. Thank you once again, sir, for your informative lecture, sir. Next time we will also have this type of lectures. Thank you, sir.
Thank you.
Thank you so much, sir. Thank you so much.
Thank you, sir.
For question answer.
Participants, if any question, can ask.
Suppose there are no questions, तो 2-3 मिनट और ले लूंगा मैं आपके. मैं खाली ये बताना चाहूंगा कि मैंने जो वर्क किया था, मैं थोड़ा पे हिंदी में बोल रहा हूँ, कोई दिक्कत नहीं है. मैंने जो इसमें हाइड्रोट्रॉपिक से एनालिसिस वर्क किया, टाइट्रीमेट्री यूवी एनालिसिस वगैरह, तो अपने इंडिया में बहुत सारी कॉलेजेस में होने लगा और इतना वर्क इकट्ठा हो गया, एक चैप्टर लिख दिया. 4 एसोसिएट प्रोफेसर टाइप की जो उन लोगों ने लिखा, ये ग्रीन केमिस्ट्री की बुक है, उसमें 13 चैप्टर है. उन चैप्टर में से 6वां चैप्टर जो है उनका, वो इस पर है, ग्रीन हाइड्रोट्रॉपिक टेक्नोलॉजी पर. यानी इसमें पूरे थे वो सभी यानी विदाउट ऑर्गेनिक सॉल्वेंट जिनने यूज किया वो सब इसमें आ गए। कुल मिला के बात ये है कि जो 2004-5 से जो शुरू हुआ था वर्क अपने इंडिया में, वह अब इतना हो गया कि विदेशियों की नजर गई इसमें। वो एक इजिप्ट का, एक सऊदी अरब के 2 लोग और जापान के लोगों ने मिलकर ये चैप्टर लिखा है। और वो खुशी है कि इंडिया से आज अपनी जो कॉन्सेप्ट है हाइड्रोट्रॉपिक सॉल्युबलाइजेशन से एनालिसिस करना बिना ऑर्गेनिक सॉल्वेंट के, ये पूरा इंटरनेशनली रिकॉग्नाइज हो गया। और ये जो बुक है, इट इज ऑफ स्प्रिंगर पब्लिकेशन, विच इज वन ऑफ द बेस्ट पब्लिशर इंटरनेशनली रिकॉग्नाइज, तो उसमें हो गया। और इसलिए अब जो है इसको वर्क और बहुत ज्यादा बढ़े, और ये 2021 में ये बुक पब्लिश हुई है। चलिए, बहुत बहुत धन्यवाद आप सबको लेक्चर के लिए।
Thank you so much.
Thank you, sir. Participants.
Sir, excuse me, madam. Sir,
Yes, sir, yes.
if यदि किसी को भी कोई भी यदि क्वेरी होगी आपके मतलब आपके लेक्चर से रिलेटेड ना, तो मैं आपको डेफिनेटली मेल करूंगा पार्टिसिपेंट्स की भी आपने। और डेफिनेटली नेक्स्ट टाइम हम चाहेंगे कि सर ऑफलाइन आप हमारे इंस्टीट्यूट आए, एक अच्छा सा लेक्चर करवाएं सर। बहुत ही फ्रूटफुल और बहुत ही नॉलेजेबल लेक्चर रहा। थैंक यू सर फॉर गिविंग योर प्रीशियस टाइम। थैंक यू। जय श्री कृष्ण सर।
जय श्री कृष्ण। जय श्री। May I
Yes,
leave?
Participants
yes,
may
yes,
leave the
yes,
meeting.
yes.
Thank you, sir.